Hey everybody, happy Science Saturday. This is Wildcard Science Saturday, and we have included a few little toys in your kit. And you've also got probably a Kiwi kit or something similar where you need to complete a project. Don't forget to send a picture of that completed project to your coordinator so that you can get credit for April Science Saturday. So rather than doing this live, we decided to just do a series of videos. You can watch these on your own time, just to kind of explain the toys that you've got. And I've already done 3 videos. And so if you've watched any of those other 3 videos, you know I look a little bit different than I did yesterday. I had some problems with the toy for this one, so I had to go back and do some reworking and do this again. So if you've watched the other 3 videos, I have done the centripetal spinner and the balancing bird, and what's the other one? Oh, the energy tube. And so this video is for your wooden inverting top. And so really simple toy. You would think it would not have a lot of complicated science with it. But it has really actually been something that scientists have really studied in terms of how the motion of this is created and then how it behaves once it is created. And so we're going to talk about that really briefly. I've got a couple of little videos to show you with what I have done already. And we'll kind of talk about the science too. So the first thing I'm going to do is share my screen with you. We're going to turn on the document camera so that you can kind of get a look at what the top looks like and kind of the way it behaves. So once again, look at the side of my face while I'm talking, but we're going to look at the document camera. Okay. All right. So I've got the document camera here, and I'm going to pull it down just a little bit so that we can kind of look at the top, because what's going to happen is that I can't really use the top and have any luck in you seeing what is supposed to happen. I will tell you that you'll see these tops in lots of different varieties. These are wooden tops. You can tell that the top has been or at least there's a cavity that has been drilled into this wooden top, and that wooden dowel rod inserted into the cavity there. You'll also see these tops as plastic inverting tops. And you'll also sometimes see, especially if you look on YouTube, you'll find some videos that people have done with metal tops that they've actually machined, either out of stainless steel, or you'll see some that have been done like with aluminum. Probably the best working of these tops are the plastic tops because of their lighter weight, but also they've got a very smooth surface. You can mold them all in one piece, and so you don't have any problems with your dowel rod being crooked on the inside of your cavity. That cavity is smoothed on the inside so that it's perfectly formed. The metal ones work really well too, because they can also have that really smooth surface, but they're a little bit heavier, and so you have to work a little harder to get them to spin. So actually last night, I tried to make this video last night, and I started with this top. And when you look at that, if you look at it, you can kind of tell that dowel is not centered real well in that top. And not only that, it's loose. Can you see that I am moving that? There's a little bit of a drag. And so it pops right out of there. So I spent about 30 minutes last night trying to get this top to spin, and I absolutely could not get it to spin at all. And so I got frustrated and turned the camera off and said, okay, I'm going to go at this again on Friday morning. And so we had one more top left. And so I went downstairs to our storage room and found this one last top and said, please let this work, because if it doesn't, we're not going to have a very good video. We may not have a good video anyway. but I did get this one to work. Now, when you look at these, if you've already watched a couple of our other videos, we've talked about center of gravity. And so when you look at this balancing bird, let me pull that camera back up a little bit. When we talk about this balancing bird, we talked about center of gravity or center of mass of an object. And center of mass is the balancing point or the pivot point of an object. And if you've watched that video already, you know that for the balancing bird, you know that I had a metal ruler that I wanted to balance. And so let me just go ahead and do that again really quickly. There's a really big glare on here, but this is a metal ruler. It's a 12-inch ruler. And you'll notice that there's an extension on my metal ruler about another inch or so beyond that 12-inch mark. So if you want to talk about where the center of gravity of this is, you kind of expect with a ruler, a 1-foot ruler, for it to be on the 6 inch mark. I mean, you notice that it doesn't want to balance there. It tilts towards the heavier end. And that's because the center of gravity is not at 6 on this ruler because I've got so much extra stuff here. It's really at about 6.5, maybe a little bit beyond 6.5 inches. Now that ruler wants to pivot a whole lot on my finger, but it is balancing, okay? See, I've got not touching anything. It's balancing just a little bit past the 6.5 mark, but that's the center of mass or the center of gravity for that ruler. And so that's a pivot point on that ruler, okay? If I want that ruler to spin, and you know that you've done this with those plastic rulers, you know, that have the grooves or the openings on the inside of them, you can get that ruler to spin really evenly horizontally if you put a pencil in there and spin that thing, okay? And so that's because it's its center of mass, and that's where it's going to rotate evenly. And you can make it rotate other directions or other ways, but it's not going to rotate evenly, okay? And so I'm moving away from that center of mass, and that ruler is going to start tilting. It wants to revolve from there, okay? So it's kind of the same idea with our tops. If you want to talk about the center of mass or the center of gravity for our tops, well, I have this nice wooden sphere that's had the cavity roll drilled out of it. And so you know that the heaviest part or the place where there's more mass on the sphere is the bottom half of the sphere, okay? Because I've got all this empty space up here, so there's no mass there. It's all centered at the bottom of this. And then, you know, it's a wooden dowel rod. It doesn't weigh, this doesn't weigh very much or have very much mass. And so even when I insert that dowel rod into that cavity, this is not adding a whole lot of additional mass to the top of this spinning top. The majority of my mass is at the bottom. So our center of gravity is down here around the bottom. But when you look at one of these and you set it on the table, it's gonna wobble, okay? I don't know if you all know about the toys that were around when I was a kid, but they were called Weebles. And the catchphrase for Weebles is that Weebles wobble, but they don't fall down. And that's kind of what you can say about these things. So I can tilt that over with that dowel rod on its side, but it doesn't want to stay that way because the center of mass is here at the bottom of this top. It wants to stay, so that center of mass is at the lowest part of this top, okay? What's really cool about this top, though, is if you spin this top, you begin to see a rotation on that top. And I can't spin this very hard because if I do, it's going to go flying off the desk. That's where I got frustrated last night. I couldn't get it to do what it's supposed to do. I didn't have enough space. So you're going to have to see what I had to do to fix that problem. But again, if you look at how that is spinning, you can really see that that dowel rod starts at the top of that top. Okay. but you can see it begin to wobble and kind of turn over, all right? And so if I spin that a little bit harder, now you can see that dowel rod, move this a little bit, it's still spinning off the desk it wants to go, okay? But you're seeing the position of that dowel rod change. As these things spin, this kind of thing kind of wants to turn down on its side and roll this way, okay? All right, I got my other Weeble wobbler over here. And what you'll notice is that both of those, put my fingers on both of those things, let go. And this one's wobbling a little bit more than this one is. And the reason I think that it's doing that is because that dowel rod is so off center on that thing and it's loose. And so it doesn't necessarily want to move in a real uniform manner. So we talked about centripetal force in the centripetal spinner, this toy. And we talked about inertia, okay? And so this thing's got some centripetal force, makes it want to rotate in towards the center, but that stick's not necessarily as tightly bound, and so it is feeling a little bit of inertia, and so it's not spinning quite as well, okay? All right, now here's the other thing about these. It's going to be really hard for you to see, but you can maybe see there's a tiny little divot in there where this thing was cut, and there was probably some point that was holding this thing as they drilled it out. And so it's made a little tiny divot in there. And so this is not completely smooth, and it's wood. And so when you look at yours, you'll be able to see the wood grain on these. And know that these are not completely perfect spherical bottoms of these things. And so that's also going to cause some wobble. It's also going to cause some friction, kinetic friction as these things are spinning and moving. And so that is also going to cause some drag on these tops and cause their shape to move a little bit as well. Well, what is supposed to happen with these tops is that as they spin, if you start spinning them at a high enough velocity, is that even though that center of mass is at the bottom of your top, if you're spinning it in a circular motion fast enough, you're going to create something called torque. And torque is a rotational force. We use torque when we talk about using a screwdriver or a wrench or a tire iron to loosen or tighten the lug nuts or the bolts on a wheel. All of those things are improved if you can increase the torque. And so you'll hear people tell you, if you're using a wrench, you want to have your hand farther back on the wrench or have as long a wrench as you can, because that distance between your force that you're applying, get my hand over here where you can see if I've got my wrench here, the distance between the where you're applying the force and say a bolt over here, if you are doing it working from here with a really tiny wrench and you try to turn this way, you don't have a whole lot of motion for you and a whole lot of directional motion for you to rotate. And so even though this is rotating in a bigger circle than this, you don't have a whole lot of turn before you get that bolt to move, okay? Whereas if my bolt is sitting here and I start turning here, I've got a really big path that I'm moving. And when I do that, then I've got a lot more turn on the screw or the bolt that I'm working. And so that angular force that we're applying is also applied here. So when I spin this thing, I've applied a rotational force to the top of my dowel rod, okay? And so when I spin that force then is causing the top to spin. And there's got more mass here. So I get a little bit more motion here. This is going to spin in a bigger path than this is. And so we're going to be able to get this thing to move. Now, as it rotates and creates that torque, it causes it to turn on its side, okay? And if it's still moving and it turns on its side fast enough, then what begins to happen is that we get this big rotation on the sphere and a smaller rotation on the dowel rod. And this thing is going to move fast enough to turn the top so that it sits and balances on the top of the dowel, or that part of the dowel rod, okay? Now, you can do all you want to there. You're going to have to work to get that thing to stay balanced. And then any kind of motion, maybe not. I've got it balanced and it doesn't want to stay. But as that thing turns, it doesn't want to stay with that center of gravity above it. Okay, so there we go back again to the pivot point, or the rotation point on this thing. If my center of mass is way up here, it wants to tilt over and get that center of mass closer to the ground, so it's more stable or more steady. Okay, so we can make this top spin, and we can see that dowel rod is beginning to move down towards the ground. Well, we can do it. Let's see if it'll stay in one place. And you can begin to see that there's a little bit of rotation to it. And there it begins to slow down, and there it turns. And now that dowel rod is down at the bottom of the and touching at the table, but it's not spinning fast enough for me to be able to get it to turn right side up. Okay. So when you try this, you're going to have a smooth space, a smooth flat surface, and a pretty good amount of space. Because when you put a good amount of spin on these things, they will travel a lot. Okay, travel a lot. And trust me, I've chased them all over. I was in the hallway last night trying to get it to spin. Then I was in the hallway this morning. This one doesn't work at all. It's because it's come apart, I think. This one I finally got to spin. The dowel's put in there a little bit better. And so I think that's why I got it to spin. I still don't think it's great. I wish we had some plastic ones and maybe a metal one to test. But my idea that the plastic ones probably spin the best and the easiest. And I may do that one of these days, just get real motivated and see if I can't find another couple of examples. But we're going to work with what we've got, and hopefully yours is going to work better than mine has. But you do need that big, larger space. So, because I can't move the digital camera, that document camera, fast enough and keep it focused for you to be able to follow this along the floor, I'm actually going to stop sharing that. And then I'm going to go back and share another screen with you, because I'm going to show you a couple of videos. So you are actually going to look at hang on a second, let's do this. You are actually going to look at a couple of videos that I want to show. I'm going to get things moved around on my computer. And I'm going to open up a video, and then I'm going to share that screen with you. So, find the video, clear some of the other stuff out so that you can see what you need. All right, so you are hopefully looking at a video screen of my videos that I've taken this morning. I'm going to show you 3 different ones, mostly or 2 different ones, because I can manipulate them and you see a little bit different things with both of them. So I'm going to play this first one. And I'm on the floor in the classroom. And you can see I spun that with enough speed to get that top to flip. And so I'm going to run that again. Come on. All right. That change looks like it happened. Well, it does. It doesn't look like it does. It happens really, really quickly if you get that thing to spin fast enough. And so I'm actually going to back myself up so that you can see a couple of things. So there I start the spinning. Get my hand out of the way. And you can see the dowel rod. And it's already tilted over closer to its side. And then I'm going to pull back just a hair. Let's see. Still spinning. And right there, you see that air underneath the wooden top. And I like how I'm leaning my head down as if I can see underneath that. But what has happened is that dowel is on the other side and it has connected with the ground. And because of that rotation, now we're beginning to get that top to lift up, okay? And so if I move it just a little bit farther, you can see right there, there's the dowel rod. And there it is again. And so I'm not quite vertical yet, but I'm getting really close. And so as I spin, just about at that point, I'm almost completely inverted, okay? It's almost turned all the way upside down. It's not quite there yet. It's tilted just a little bit towards me as I'm holding the camera, but it is really close, okay? Now, what's happening now is that it's spinning that little bit of space there. And you'll notice that even though that bottom looks like it's spinning a lot, it doesn't look like I've got much of that top turning, okay? So that's where that torque is coming in. This thing's not turning a whole lot. This thing is turning a lot. And so I don't look like I see a whole lot of motion up here, even though I can track it and see all that motion down below, okay? And what happens is that it's just so heavy on the top that it just can't hold on for very long. And so you see, I did a 7-second video and, you know, here we are at whatever speed, whatever time that is, about 6 seconds or so, less than that, 5 seconds. And I'm already done. The top has now laid back down on its side. And now it's just going to roll around on the ground until it finishes spinning, till it's expended all of that kinetic energy. And then it's just going to lay on the surface of the floor. And so when that happens, see, we're just spinning around on the floor and there we stop, okay? So there's one of those videos that I wanted to show you. And now what I want to do is show you the second video. And this one I liked because even though it happened really fast, I got a really good angle for that top spinning again. And it spun inverted for a really long time. So there it is. I'm not quite up. There it goes up. And now I'm right there. Just looks like it's completely inverted. And now here we go again. Lots of spinning on the bottom, not as much spinning on the top. It doesn't look like. It's because that top has we made a mark on it. It's got a lot farther to go. And so we just begin to see that spinning all over the place. It's beginning to lose that energy again, friction with the floor. And if you look, you can see all those places there? That's where wax has been knocked off of the floor. And they've gone back in over the top of it and waxed it again. And so that surface is not really all that smooth. And so I've got lots of interactions with the floor that collisions that kind of help it lose a little bit of energy as well. And so now I'm just at that spinning on the floor. So I actually have 3 of these videos that actually show that top lifting up off the ground and then falling back down again, or not lifting off the ground, but inverting. But I bet I took 20 videos this morning. So I'd take one, try to get it to happen, throw it in the trash because it didn't do what it was supposed to. Lost it under tables and chairs a whole lot, did a whole lot of trying to figure out a way to make this happen until I got 4 meter sticks and put those on the floor and gave myself kind of a boundary to work in. And if it was spinning well enough, it would hit the side of one of those meter sticks and then it'd just spin back the other, move its direction, change its direction of motion while it was still spinning. And I was able to get it to invert a little bit while it was doing that. So be prepared to chase after it when you're trying it. But it's pretty cool to watch it happen. And then I'll see if I can't come up with some other types of spinning tops and see what we can look at in terms of making that happen. Okay, so we're talking about some angular velocity, some rotational motion. We talk about torque. There's friction that's involved. Talk about center of mass or center of gravity again. And we'll talk about potential and kinetic energy. You know that energy is conserved, and so every bit of energy that is applied to the top when I spin it has to still be somewhere when it is when I'm finished spinning the top. And so I'm putting a lot of potential energy into it, or putting a lot of energy. Well, yeah, I guess it's potential energy. A lot of potential energy into it with my spin. It's rotating. As it's rotating, it's converting that potential energy to kinetic energy. But at the same time, it's rolling across that floor. So there's friction there. And even though the floor is not going to feel hot and the bottom of the top is not going to feel hot, a lot of that kinetic energy is getting lost due to friction as what we call heat energy or thermal energy. Because if you rub 2 things together long enough, you begin to feel some heat generated because of the drag that's created. Okay, so a lot of really cool physics in this little top, and a whole lot of people, believe it or not, have done research and published papers on what is happening, and why they think it's happening, and what's causing it to do the things that it does. And so you wouldn't think that a whole lot of research would go into creating a little top, but believe it or not, there's been a lot. So there is the last of my videos that I'm going to make for you. Hope you have had fun playing with your toys. You can go out and throw out all those physics terms to your science teachers and your friends and neighbors and impress them with what you have learned in terms of your toys. Okay. Don't forget to send pictures of your kit production to your coordinator. And last Zoom Science Saturday for the year, and we'll start up again in September. All right, talk to you later. Bye.